All right, good morning, guys. Y'all can start taking a look at the do now. We'll go over it in a second, but we're going to wait a little while to make sure other people don't join. Okay, Brady, it's fine. I'm going to post a recording of the Zoom later today. So if you do get cut out or lag, you can look at it later. All right, still going to wait 1 or 2 more minutes to make sure nobody pops on, and then we'll go over the do now. for the do now, think back to the geology doodle notes that you did yesterday. So the 3 different types of plate boundaries. Somebody give me one of them. Anybody? Guess I'm talking to my empty classroom. So the first one that we talked about, when plates pull towards each other, is called convergent. Okay. When plates pull away from one another, it is called divergent. And when they slide past each other, it is called transform. So make sure you've got that on your do now to hit submit. All right, and before we move on, does anyone need me to show the part 3 video to the doodle notes? If you need me to show it now, please say something or put it in the chat, because otherwise we're just going to move on and I will assume you have done it through the YouTube video. So nobody needs me to play the part 3. Okay, Zay, did you get any of them?
Huh?
Did you get any of the doodle notes? Did you do part 1 and 2 or no?
I believe I did.
Okay, do you have your Canvas is working and your YouTube's working?
Yes.
Okay, if you're not done with the doodle notes, use the YouTube videos. I have it linked in Canvas for yesterday. Has part 1, 2, and 3.
Is it in the announcements or assignments?
It's on the modules tab under the Unit 4 module.
Oh, give me a minute. Under today's date?
Under yesterday.
Huh?
Yesterday, because that's what we did yesterday.
Google Doodle Notes?
Yes.
Whatever the word is?
Yes.
All right, gotcha. I'll look at it.
Okay. So since I don't have enough time to play all 3 videos, y'all do that when you get a chance. And make sure you take a picture and submit so you can have points and credit for doing that.
Take a picture of the video.
Of your piece of paper, like when you're done.
All right.
I was gonna give y'all a printed out version of it, but since we're not in school, just kind of sketch the pictures that are on there to the best you can. I'm not worried about your drawings. Just kind of, listen, take some notes. All right, so make sure if you have not done those, everybody, that you get those completed. But we're gonna move on for today. Where am I? Okay. All right, so we are going to just briefly go over some slides that kind of review what the doodle notes were supposed to tell you yesterday, just to make sure that we've got it and we kind of understand what's going on before we move into the next thing. So the geology doodle notes basically talk all about plate tectonics. And we know that the Earth is made of layers. This top layer that includes the crust and where we are, so this gray part, is called the lithosphere. Underneath that, this red area is called the asthenosphere. And in this area, it's red because this is where all that molten rock is. So it's all partially melted. And that melted rock goes through what we call convection currents. And that's why you see these little circles with arrows in them, because that means that, you know how people always say that hot air rises? Well, same thing happens with melted rock. So the hotter melted rock starts to rise, and as it cools off, that cooler melted rock starts to sink. And it makes these convection currents and these little circles of hot and cool rock moving around. And so where this cool rock is coming down right here, and this other current, it's also coming down. So they kind of alternate directions next to each other. And then under that asthenosphere, we have the mesosphere. And plates are less dense. So on the crust, the lithosphere is made up of our plates. And what they mean by that is the continental plates, like where we live, that have land, and the ocean plates, so that land underneath the ocean that kind of holds the water up. Both types of those plates are less dense than all of this melted rock underneath here. And so our plates are actually kind of floating on top of melted rock. So our oceans and our landforms are on plates that float on top of melted rock. So starting on to the plate boundaries. The first of the three types that we talked about is called convergent. And in convergent plates, you have plates that push towards one another. So they come towards one another, and these plate boundaries are typically what causes volcanoes, because whenever this plate starts to go down and this other one's pushing up, this hot molten lava starts to push through and form a volcano. These convergent boundaries can also cause earthquakes, but it's not the most common cause of an earthquake. Also, in the doodle notes, they talked about on convergent boundaries when an ocean plate and a continental plate, so an ocean plate and a land plate, when they start to push together, an ocean plate is a lot more dense than a continental plate, because ocean plates are made of a type of rock called basalt, and it's a lot heavier, thicker, more dense rock than what the continental plates are made of. So when they start to push together, something happens called subduction. So that ocean plate, since it's a lot heavier, goes underneath and kind of sinks under the continental plate. So you can think about it like having two pieces of paper on a table. If you slide them towards each other, eventually one of them is going to go underneath the other one. And that's kind of how the same thing happens in subduction. When those plates come together, the heavier, more dense ocean plate is going to go underneath the continental plate. Then in divergent boundaries, this is when plates push away from one another. So this can form ridges, it can also form volcanoes, but this is typically what causes the seafloor spreading. This can also cause earthquakes, but again, it's not the most common cause of earthquakes. So in the ocean, a lot of times that's where this happens. The plates start to pull apart and they separate, and all of that molten rock and that lava underneath the lithosphere or underneath the Earth's crust starts to come out and peek through. So when that hot molten rock comes up and it reaches that cold ocean water, it starts to cool off and harden. And a lot of times this forms what we call those ocean rifts and those underwater ocean mountain ranges, because when these plates pull back, that hot molten rock comes up, cools off and hardens and forms those little mountain ranges underneath the ocean, or underneath the water in the ocean. And then our last type of boundary is called transform. In transform boundaries, plates slide past one another. So they're not pushing towards and they're not pulling away, they are sliding past one another. This type of boundary does not form ridges and it does not form volcanoes, But this tends to be what causes earthquakes, because when these plates slide past one another, the edges of them are typically pretty rough. And so when you try to slide them past each other, a lot of times they kind of get stuck and they don't want to slide past each other. And so when they get stuck, all of that pressure and energy from that hot molten rock that's moving underneath starts to build up. And so when that pressure builds up, when they're stuck next to each other, it starts to shake, and then they finally break and kind of snap apart. And that's what causes our earthquakes. So when they get stuck, all that pressure and energy builds up, and that kind of makes the ground shake, and they try to push past each other. That is what causes most of our earthquakes. So if you think about when you hear about all the earthquakes in California and over on our west coast of the US, they are on a transform plate boundary line over there, and that's why they have a lot of earthquakes, because those plates are sliding past each other and all that energy is building up and causing them to shake. So plate boundaries, we have a lot throughout Earth, and plates are constantly moving in kind of all directions. So plates don't just sit still, they're kind of always moving. And each plate does not necessarily have one type of boundary. Each plate can have all three different types. So if we look at this big main Pacific plate right here, you look over on our west coast over by California, you see the purple line saying that it's a transform boundary. So where those plates are sliding past each other, that's why we have a lot of earthquakes over there. But then if you move down, you see some of this lighter blue color where there's a divergent plate boundary. And as you move around, they have also the darker blue color that represents the convergent boundary. So one plate can have all three different types of boundaries. And then also remember that the movement of our plates and what type of boundary they have on these plates determines a lot of the geologic features in that area. So in those areas where there are convergent boundaries, a lot of times that's where volcanoes will be. Places where there are divergent boundaries, that's a lot of times where those ocean mountain ranges are, or where there's a lot of rifts where the ground has separated. So these plates really determine a lot of our geologic features. So this picture shows that different geological features that can be formed because of different plate boundaries. So if you look over here by this convergent boundary caused a volcano, over here a divergent boundary on land caused a rift zone. So it's kind of like a big valley over there. Over here by another divergent boundary, you have an ocean rift, or where it starts to form a little mountain range under there. You also have another convergent that forms a volcano out in the ocean, which starts to form islands. So in the doodle notes, when they talked about how Hawaii was formed, it's because underneath where there was a crack somewhere, this magma started to come out and harden and start to eventually form a landform, and that's how Hawaii was made. So again, going back to the earthquakes. So earthquakes typically happen because of our transform boundaries. So when those plates start to slide and lock up at the fault lines, and when all that energy builds and releases, that is the ground moving and the earthquake that we experience. So there are a lot of things that can result from plate tectonics, such as earthquakes, volcanoes. We know these volcanoes can actually form islands. They can also form tsunamis. A lot of times those plate boundaries where earthquakes happen, it causes the plates to shift, one of the plates to shift upward, and it pushes a lot of water up and creates a big wave. And we know that when these tsunamis happen, it has a lot of consequences. It can destroy habitats, drown species, uproot trees, contaminate our water. So there are a lot of major consequences that stem from these plates moving and shifting and causing tsunamis, causing earthquakes, volcanoes. So there's some other resources if you're interested in looking more into this. But the next thing that we are going to do is, if we were in class, I was going to give you some Oreos and we were going to kind of demonstrate how these plate boundaries move and how the different types work. But since they sent us home on virtual, I found a video of someone actually doing the same thing that we were going to do in class. So there's a link to the video, but we'll kind of watch it together and stop it at different points to go through the worksheet. So I need everyone to find this Oreo Cookie Tectonics worksheet. And when you open it up, make sure that you click File and make a copy so that you can type on it. So I'll give everybody a second to find the Oreo Cookie Tectonics worksheet. Make sure you click File and make a copy so that we can start working on it together. Make sure you've got the sheet pulled up, you've clicked File, make a copy. And I'm going to pull up a version where I can write on it while y'all are getting that done. All right, so looking at the top part of the worksheet, it has a section for us to label the diagram, and it gives us 6 different terms and places to label. So if we were going to start on this diagram, look at the center part, labeled number 4. Does anybody know what we would call this? Number 4 right here. Yes. So number 4 is our inner core. Okay, and then moving out one level to number 3, if this was the inner core, obviously this is going to be our outer core. So make sure you're filling out your sheet as we're going through this. Moving out to the next 2 levels. So 1 and 2 are considered our mantle. And since we are out here on the earth, number 1 is lower than number 2. So number 1 is our lower mantle. And then number 2 is above the lower mantle, so it is our upper mantle. Right, and then I'm going to skip 5 and 6 for a second, and I'm going to come back to them, because I'm not a huge fan of this diagram and the way that it is sectioned and labeled. So I'm going to explain the terms lithosphere and asthenosphere before we label 5 and 6, so that maybe it'll make a little more sense of why I'm not the biggest fan of this model. So the lithosphere, yesterday on your doodle notes, we know that the lithosphere is like the outer crust, and this is where we are located. So the lithosphere is the rigid outer part of the Earth. That looks weird. Consisting of the crust. So lithosphere is where we are. It is that outer layer with the crust. And then the asthenosphere, talked about in the doodle notes as well. We know it's the layer under the lithosphere that has all of that melted rock that goes through convection. Remember, convection is where that hotter molten rock is rising and the cooler molten rock is lowering. So we have all those convection currents in there. So the asthenosphere is the upper layer of the Earth's mantle. It is below the lithosphere. Composed of partially molten rock. And it is where convection occurs. I'll give you a second to make sure you have that down. All right, and going back up to labeling our diagram. So 5 we know is our outer layer and crust where we are, so that is our lithosphere. And then the reason I'm not a huge fan of this diagram is because we know our asthenosphere also includes the upper layer of the Earth's mantle, so I don't really like how they have it separated as its own little thing. It should also include some of this mantle over here, but 6 is our asthenosphere. So make sure you have all of that caught up before we move into watching the video. All right, so since we couldn't do a little cookie modeling in class, I have a video of someone doing exactly what we were going to do anyway. So we'll watch it together and kind of go through the worksheet together.
Hi, welcome to the Oreo Cookie Plate Tectonics experiment. This experiment can be used if you complete the questions on the worksheet as one of your days of assignments. So this can replace one of your review worksheets for the week. For this experiment, you only really need two things: Oreos and some sort of cleanup device. I have paper towels. Once you have those two items, you're ready to begin. For this experiment, I'm going to be using 3 different Oreo cookies, one for each type of plate boundary. So the first thing you'll have to do with each cookie is twist the cookie lid, I like to call it, so that you have one cookie with cream on it and one cookie without cream on it. You'll want to do that for each cookie. Okay. The cream of the cookie is going to be representing the asthenosphere of the mantle, so that more liquidy plastic layer of molten rock. The cookie without any cream on it is going to represent the lithosphere, so the uppermost mantle connected to the crust. Okay. Now, because we're going to be looking at how 2 plates interact with one another, I also want you to very carefully break that lithospheric cookie into 2 plates for each one. All right. Now, we're going to be starting with a divergent plate boundary. So I'm going to set 2 of these cookies aside for now, and we're going to focus on just one cookie. So we have the lithosphere of our broken plates up here on the top, the asthenosphere or the cream in the center, and we're going to be modeling a divergent plate boundary. Divergent means that these 2 plates are going to be moving in opposite directions away from one another, okay? So we're going to be basically modeling a mid-ocean ridge where these 2 plates are going to be pushed away, allowing for new magma from the mantle to come up through. Now, how to do this? I recommend starting with your 2 plates pretty close together, pushing down on them gently as you slide them away from one another. Okay? Now, my bottom cookie did break, and that's okay. It might happen to you too. We're mostly focusing on the top cookie. So from above, you can see that now there is visible magma from that asthenosphere of the mantle. When that magma cools, it will form new rock. It will form new crust. So this is one of the ways that the plates on our planet are actually growing. This is where the new crust is going to form. If you look really closely, because I pushed down, you can also see that the cream of the cookie has formed a little bit of a mountain peak. That's going to be our underwater mountain range, that mid-ocean ridge, okay? If these 2 pieces of crust, these 2 lithospheric plates, if they were continental plates, we'd be forming what's called a rift valley, where you'd have basically a canyon in the middle here. Underwater, this would form a mid-ocean ridge. So that's our divergent plate boundary.
We'll go back to the worksheet. Select the next part. Okay. So 1 is when she took the top cookie off, moving to 3. So when she broke the upper cookie in half, what sound did you hear? So it was really like a snap or crunch sound when she broke that top cookie. And then what does the breaking represent? So remember that the top cookie represented the lithosphere, so the crust, the outer portion of the earth. And that lithosphere, when it was broken, formed our plates. So it's the breaking of plates. Right, and let's look at divergent plate boundaries. Divergent means that the plates are pulling away from each other in opposite directions. The plates are pulling away from each other in opposite directions. And then for 5, it's asking when she pushed down on the 2 cookie halves and she slid them apart, what happened to that creamy filling? So when she slid apart, you could start to see the cream or the magma, and it formed almost like a little mountain ridge in there. So explain that to me on number 5. When she pulled them apart, what happened to the creamy filling? And then for number 6, it says draw. But since you are on Google Docs, I want you to explain a divergent plate boundary. So what happens in a divergent plate boundary? Explain that on number 6. So I'll give you a minute to work on 5, explain what happened to the cream, and then on number 6, explain a divergent boundary. So now we'll go back to the video and watch the next type of boundary.
Okay, so we'll set that one here and get a new cookie. The next plate boundary we're going to be demonstrating is a convergent plate boundary. Specifically here, we're going to be making a convergent plate boundary between 2 continental plates. It's a little bit tricky to do this with a continental and an oceanic to show subduction. These 2 pieces of cookie are the same density, the same thickness, made of the same materials. So we're going to say that they are 2 continental plates. If this is a convergent boundary, it means that these 2 plates are going to be moving towards each other. Sorry, I have some black food coloring from my other experiment on my finger. These plates are going to move towards each other. If one of these was an oceanic plate, remember oceanic plates are really, really, really dense and heavy from the water and the dead plankton that have soaked into them. So if we had an oceanic plate here, we'd actually see one of them sinking through the process of subduction, which could form some volcanoes on the top plate. But because we're saying these are 2 continental plates, we're not really going to get any subduction here. So just like before, we're going to very gently press down on our plates, but this time instead of moving them away from one another, we're actually going to push them towards each other. Okay. And you can see we've gotten some cream to squish up through it, forming a little mountain peak there on our plates. Okay, so this is a convergent boundary. Now, if you kept pressing these together, eventually you'll even get, do you see how the Oreos themselves are kind of pushing up? and forming a little mountain range. This is how the Himalayas, like Mount Everest, were formed at a convergent plate boundary between two continental plates. Okay. For our last plate boundary,
let's go back to our worksheet. Is that the next part? All right, so convergent plate boundaries. Convergent means that plates are pushing towards each other. Pushing or pulling, however you want to word it, towards each other. Okay. Number 8, explain of what happened to the filling when she started to push the two cookie halves together. So tell me what happened to that filling, how it came up to the middle, it started to form almost like a mountain peak. Number 9, what happened to the cookies? So after she pushed together, that filling started to come up from the middle. She kept pushing, and what happened to those cookies? They actually started to come up as well. And then I'm gonna help you out with number 10. When one plate slides under another plate, there's a term for that. So think back to before she started, she said that we couldn't really demonstrate an ocean plate and a continental plate because they have different densities. An ocean plate is a lot more dense. It's made of basalt, so it's heavier, more dense material than a continental plate. So when those two plates start to push towards each other, that heavier ocean plate is going to kind of sink up under or slide under the continental plate. And that process is known as subduction. Okay. And then for 11 again, instead of drawing a convergent boundary, I want you to explain a convergent boundary. So work on 8, what happened to the filling, 9, what happened to the cookies, and 11, explain that boundary. I'll give you a second to work on that. Right, now I'll watch the last part and you'll have a little time to finish this.
Boundary, we're going to be looking at a transform boundary. Transform boundaries are a little bit different than the other two in that we're not having any like side-to-side motion really. What's happening here is these plates are going to be sliding past one another in opposite directions. So maybe one of them is going north and the other's going south, or one is going east and the other's going west. This one directly impacts the United States because we have some boundaries like this on our west coast, California, Washington, Oregon. Those areas are right along a transform boundary. If you've ever heard of the San Andreas Fault, what the San Andreas Fault really is where these two plates are next to each other and they're sliding, okay? So for this one, we're already gonna start with them pretty close together. I'll move one up and one down as I slide them on the cream here. And can you hear that? there's some friction there. There's some tension. You can see I shaved off some cookie down here. As it slides, it's not always easy to do that. Sometimes you get stuck and you have to push a little harder and then the cookie moves suddenly. When you get that sudden movement of the cookie, that would cause an earthquake, which is one of the reasons there's so many earthquakes in California. If I pick this up off of our little mantle, you can see I've left a lot of cookie shavings behind. I'm actually grinding away the sides of these two plates, okay? If I hold it closer to the camera here, as I slide these, you can see it's actually smoothing the sides of my plates that they don't match up perfectly anymore. I'm actually grinding away some of the cookie, some of that continental plate. And that happens in real life too, which is why you get this deep crevice between these two plates as they slide past one another. Okay, so those are our 3 different types of plate.
So back to the last part of our worksheet. All right, so 12, transform plate boundaries. Sliding the 2 cookies past each other, what did you notice about the cookie edges? So think about how at first they were rough, they didn't necessarily want to slide past each other, and then eventually they kind of ground down a little bit where they could slide and it left a ridge in between. So kind of explain that to me on number 12. And then for 13, same thing, instead of drawing, just explain a transformed plate boundary. So that'll be all that I have for you today. So you have about 10 minutes where you can finish up this sheet. Make sure that you upload it into the assignment on Canvas so that I can grade it and give you good points. And as long as you don't have any questions, you're good to go. Make sure if you did not finish those doodle notes and get those uploaded that you do that as soon as possible. And y'all have a good day.